Finally, I have landed into GenAI learning, which is one among my most focused area of learning. In this video, let's connect the concept we have learned so far to a real production style GenAI application. In my previous video, we have come across how LLM works internally, and also we have come across terms like embeddings, attention mechanism, transformers, etc. Now comes to an important question. With all this knowledge, as a software engineer, how we are going to build a real GenAI application? When does prompts come into the picture? When do we need RAG? Why do we need embedding? And what exactly a GenAI engineer build around an LLM? In this video, let's connect the concepts we have learned so far to build production style GenAI application. When we first start learning GenAI, it may look very simple. The user gives a prompt and we will send a prompt to an LLM and the LLM gives a response. But a production GenAI application, it is much more than this. Let's see how the GenAI application looks like. You can see here the user might be posting a query or a prompt, and the front end will be sending this prompt to the backend API along with authentication. The backend will create a prompt including system instructions, user query, and the context. And this prompt will be converted into embeddings, and it will be searching in the vector database, and it might also call tools or APIs if required. And finally, this is sent to the LLM, and from the LLM, the response from LLM need to be validated using guardrails, and the response is finally posted back to the user. The LLM is only one component of the application. As a GenAI engineer, we will be designing everything around the LLM. Let's consider a real world example, maybe enterprise HR assistant. Let's imagine our company want to build an internal AI assistant. Employees should be able to ask questions like leave policy, company benefits, travel policies, etc. Now let's see what actually happens when we build this application. Does the LLM already know our company policy? Probably not. Let's think employee ask a question, what is the maternity leave policy? Even if LLM knows some general information about the company, still we cannot rely on the LLM. It's better to give a latest update on the company policies. So we need to provide the correct information. This introduces the need of RAG. When user posts a query, it doesn't post just a query to the LLM. Instead, our backend will construct a prompt. It might be including user query and system instruction, business rules, retrieved context, and the final prompt is posted to the LLM. Our backend application may construct a complete prompt, and we can see that prompt. This is one of the place where GenAI engineer applies prompt engineering in the real application. Let's imagine we have 10,000 documents. Do you think are we going to send 10,000 documents to the LLMs whenever a user posts a query? No. This is where embedding comes into the picture. We will be splitting company documents into chunks, and these chunks are converted into embeddings. They are nothing but vectors, and they are stored in the vector database. Whenever the user posts a questions, they are converted into embedding, which are nothing but vectors, and the similarity search happens in the vector database, and the relevant documents are retrieved. So even if the user says, how much leave do I get after having a baby, the system still finds a document called maternity leave policy. This is semantic search. So let's see now, we have retrieved company documents. The user is asking a question with relevant context. We will be posting it to LLM and we get the answer. The complete pattern is called retrieval augmented generation, where retrieval means finding relevant information and augmented means adding that information to the LLM context. Generation means the LLM generates the final answer. RAG is one of the most common architecture used in enterprise GenAI applications. Now the question arises, why do we need LLM fundamental knowledge where it matters in production? Let's say that these concepts are not just theory, they directly affect how we design and debug GenAI application. If your API cost is more, you need to understand tokens. If your chatbot is forgetting earlier information, then we need to understand context window. If your answers are too random, you need to understand temperature. If your chatbot is giving wrong company information, then we need to understand RAG or retrieval. If your search results are poor, you may need to understand embeddings and chunking. This is how we move by understanding how LLM works internally to actually building GenAI application. The LLM is the intelligence engine, but a production GenAI application includes much more: prompts, embeddings, retrieval, vector database, RAG, structured output, guardrails, tools, evaluation, and backend architecture. As we move further, we can understand where they fit into a real production application.